Welcome. In this e-learning module, I shall demonstrate and make you understand how to create the spring design using Catia v5. In the previous e-learning module, we had selected spring of inner dia 17.5 mm, outer dia 35 mm, and free length of 70 mm. The press tools are always designed in the closed condition, which is at the bottom dead center. Hence, the 3D design of stripper spring is created in a compressed condition. Now let's create the 3D design of the spring. We will design the 3D as per this geometry. Create a new part file with the part name as stripper spring. Change the workbench to wireframe and surface design. Pick on the helix command. Select height and pitch for the helix type. Enter the pitch as 4 mm. Enter the height as 60 mm. This is the compressed length of the stripper spring. Right-click on the starting point and select Create a Point. Enter the Y value as 17.5 divided 2. 17.5 is the inner diameter of the compression spring. Click on Preview, make sure the point is getting created, and then click on OK. Right-click on Axis, and then select the Z component. Click on Preview, make sure the helix is getting created, and then click on OK. Change the workbench to Part Design. Create a sketch on the front YZ plane. Sketch a rectangle, with the first corner of the rectangle snapping to the horizontal axis. Sketch a centerline on the vertical axis. Create a diameter dimension between the center line and the right side of the rectangle. This is the outer dia of the compression spring. Provide a coincidence constraint between the start point of the helix to the start point of the rectangle. Observe the sketch is over-constrained. Delete the unnecessary dimension. Change the diameter dimension to 35 mm. Change the height dimension onto 2 mm. Make sure the sketch is fully constrained and exit the Sketcher workbench. Create a rib with the profile as a rectangle and the center curve as the helix. Observe an error message, and the spring is twisted. Click OK on the error message. Change the profile control to pulling direction. Right-click on the selection and pick the Z-axis. Click on Preview, make sure the spring is getting created, and then click on OK. Let's create a cut for the height of the spring. Create a sketch on the front YZ plane. Sketch a rectangle. Create a dimension for the height of the spring. Update the spring height dimension to 60 mm. Apply the symmetry constraint between the rectangle's left and right edges with reference to the vertical axis. Update the height dimension to 60 mm. Update the width dimension to 60 mm. Make sure the spring outer dia is inside the rectangle. Make sure the sketch is fully constrained and exit the Sketcher workbench. Create a cut with the Pocket command, with depth 60 mm, with a mirrored extent. Observe the ends of the spring is cut. This is the spring with ground edges. Set the view to isometric and fit all in. Save the stripper spring. Let's provide a formula for the spring. Click on the Formula command. The Formulas window opens. Click on the sketch created for cutting the edge of the compression spring. Pick the spring height dimension. Observe the height dimension is highlighted in the Formulas window. Click on Add Formula. Observe the Formula Editor window opens. Click on the helix. Select the height dimension of the helix. Observe the height dimension of the helix is highlighted in the Formula Editor window. Click on OK. Observe a formula is created, indicating the height of the spring on the pocket command is equal to the helix height. Click on Apply, and then OK. The advantage of this formula is that if you change the helix's height, the pocket's height automatically updates. Set the view to isometric and fit all in. Save the stripper spring. With this, we have successfully designed the stripper using Catia v5. That's all in this e-learning module. Thanks.